Okay, so we're talking about the distance formula today. According to the scenario that's up here, we're talking about Vicky, and she's obviously not Superwoman here or whatever else, but she's trying to figure out the shortest distance from herself to her brother. Now, she could count the sidewalks. So if she went down this way, this is, 5 blocks this way, and then 5 blocks this way. If she walked that way, it would be a total of, 10 blocks, right? Okay, but she wants to find the shortest distance. I don't know why she wants to find this, but she wants to find, sort of as a bird flies is usually what they say, this distance, okay? Now, we've already studied this in the form of vectors, haven't we? If we were to write this as a vector to move from where Vicky's at to where Scott's at, we would say that she moves negative 5, 5. And we put them in those little kind of arrow things. We've already done this with the vectors, okay? So today's lesson is not tough, because with vectors, all we did was we basically said, hey, this is the square root of, then we took negative 5 squared plus 5 squared, and we would just really easily, this would be 25, and 25 is the square root of 50, and we'd get an answer of 5 times the square root of 2, okay? And that's just, I simplified it really quickly. But then later on, we studied this and we said, well, hey, if this distance is 5 and this distance is 5, technically this is a 45, 45, 90 triangle, okay? And if this is 5, this is 5, this has to be sort of the side length times the square root of 2. So does that make sense why it's also 5 times the square root of 2? Yeah. So we've kind of done this already twice, and we're sort of just combining the ideas and just kind of formalizing, talking about what the distances is. Yes? Oh, yeah, I guess you're right. You're right. This would be negative 5 as we do this. And remember, whenever you put this in your calculator, you need to make sure to put this in parentheses, or else you're going to get like negative 25. Distance is never negative, okay? So your distance that you've traveled, we can never say, well, I traveled negative 5 miles to school today. That doesn't make sense. You traveled 5 miles, okay? Distance is just a length. But then when you talk about direction, you could say, well, it's the opposite direction or it's the positive direction, something like that. Okay? So we know how to solve this. We kind of know this idea. And we're going to jump in. We're going to see a formula that looks a lot like this. But I like the idea of sort of breaking this into vertical and horizontal components, realizing that this is going to be some sort of right triangle as we're moving. The interesting thing here is if we made points out of this, we could say like S is the first point, and since he's on, let's see, 2nd Street, we could say this is 2. He's on 3rd Avenue, so we could say that's up 3. That could be like our first point. And then down here, this would be, let's see, she's on 7th, and then she's up at 8th Avenue, so that's like 7, 8. What would this point right here be, where they intersect? The lines intersect. Where's that at? That's over 7, up 3. Okay, so there's another way that we could actually find these lengths in case you can't necessarily count them for some reason. You could just say, well, hey, 3 minus 3, well, that's, since those two are the same, it's a distance of 0, right? We haven't moved up or down any. But 7 minus 2 is 5, so that's one way to find that length, is to basically realize this is like this x-coordinate minus this x-coordinate is the 5. Since the 7's here are the same, we could just do 8 minus 3 to get the 5 as well. It's just another way of finding that distance in case you just can't count the squares. Okay, down below it talks about how you can think of a coordinate plane as a grid of streets, basically breaking each one of these down into vertical and then horizontal components. This would be the horizontal and the vertical components, but basically breaking each and every single one of these down, no matter what the side lengths are, into little pieces, so that you have right triangles and can then use, for the most part, the Pythagorean theorem to find the distance of the hypotenuse. Wow, I did spit out all the right words. Okay, but it says that's really nice if you have it sketched and it's drawn and you're taking a little sip of water. That's fine, but it says down here, it says, what if the points are so far apart that it's not practical? It's not practical to plot them. Practical just means, well, there's no way that I want to plot these giant points, 1534 and 4270. I'm not going to draw that, and I'm not going to be able to get those little things. So it says there has to be a better way. There's got to be a better way to do this. Okay? Well, Well, all we're really doing is we're looking at the distance between the x coordinates and the distance between the y coordinates, right? That's what gives us these, okay? So if I was to do this, what's the distance between 42 and 15? What's the distance there? What's 42 minus 15? That's 27. Okay, so our x distance, our change in our x is 27. If we have 70 and we subtract 34, what's our distance for our y? That's 36. Okay, so we can do something where we're actually finding, well, here's this distance, here's this distance. And don't we basically square each of these? We add them together, and we'll basically take the square root of this stuff. So we're basically squaring these guys, adding them together, and doing this. That's how we actually find the distance, okay? Just like we would take the square root at the very last step when we're using the Pythagorean theorem, we'll just throw the square root in there right away in order to do this. So let me formalize this just a little tiny bit. The distance formula. Okay, I'm going to write it below the line. If you want to write it on the line, that's fine. But our distance formula, if we're given points x1 like this, okay, all we do is always the square root, okay? And what we do is, it doesn't matter whether you start with the x's or the y's. It does not make any difference. I'm just going to start with x2 minus x1. So it's kind of like slope. You square this, then you're going to add it to y2 minus y1, like so. Okay, that's the distance formula. So it's your difference of your x's. Notice that I'm starting with x2 and I'm starting with y2. Generally, you start with the second one and you subtract the first one. Just like that last thing, we started with 70 and we subtracted 34. Okay? So you generally speaking start with the second one and subtract the first one. You'll add those together, you'll square them, and you'll take the square root of the whole thing. Order of operations for this really does matter. So we're always going to subtract these things first. We're going to square them individually. We're going to then add them together. We're then going to take the square root of the whole thing. If you're really good about it, you can probably put the entire thing into your calculator. I don't. I generally don't use the calculator a whole lot. I do use it a little bit in order to get certain answers. I think we're on the back side now. Does anyone have any questions about that formula? Why don't you go ahead, why don't you write on the back as well, distance equals, and just write out that formula really fast. That's your, in parentheses, you're changing your x's, x2 minus x1 squared. You're going to add to that the difference, so the change in your y, so y2 minus y1 squared. Okay. The subtracting, really this will give you like basically your x distance. This gives you basically your y distance. So with your triangle, if it looked like this is basically your x distance, this is basically your y distance, and then d is going to be basically your hypotenuse. That's what we're looking at. Okay, so for this first one, we just say the distance is going to equal the square root of, we just write -4 minus 3, and we square that. We can think of this as x1, y1, x2, and y2. We just take the y coordinate minus the other y coordinate. We're going to add that -1 minus 7, and we'll square that. Okay. I just do the rest of this in my head for just a little while. Not all of it. But -4 minus 3 is -7, so that's -7 squared. -1 minus -7 is actually -8, and I'm going to square that. Whether it's +7 or -7, you're going to get the same answer when you square them. What's 7 squared? 49. And what's 8 squared? 64. I'm going to add those two together, and that's basically going to be my answer. What is that, like 113? Now, can you simplify 113, the square root of 113? What's that? You got 41. Well, 9 plus 4 equals 3, or 13, so. Oh dear. Well, I'd say something happened wrong somewhere. I'm not sure where. Okay, but since you can't simplify this any further, we're just going to leave this like this. That's what the directions say. It just says determine the distance between each pair of points. Do not give a decimal answer. Answer should be in simplified radical form. Okay? Someone want to volunteer for number 2? Number 2 is really easy, by the way. You'll try it? All right. Number 2, what color do you want? Blue. Got it. Distance equals. Nope. Oh, I'm sorry. Start with x's. Start with your x's. So it's this guy minus this guy squared. Yeah, minus the -5, which is the same thing as +5, right? Okay. What's -3 minus 3? I'm asking you. -3 minus 3? What's 3 times 2? Okay. What is 0 plus 5? So it should look like that. Sierra, what's 6 squared? 36. What's 5 squared? 25. If we were to add those together, what's 5 plus 6? 11. What's 3 plus 3? 6. Can you simplify the square root of 61? I don't think you can either. Yes, sir. Say that again. No. See how I left this in parentheses? If you put it in parentheses in your calculator, a negative times a negative always gives you a positive back. Okay? So the idea here is that, but if it is 6 squared or -6 squared, since you're multiplying by itself, it'll always give you a positive number back. Yes, ma'am. Never mind? You sure? Okay. Mitchell, number 3. What color do you want? Black. All right. Sure. No. Well, hey, let's write the formula really fast, shall we? Okay. This equals the square root of, this is x2 minus x1 plus y2 minus y1 squared. Okay? So now you just need to fill in the blanks here. So what does this equal? 3? Yes. Okay? You said -5 minus a -7. Minus a negative is the same thing as plus. Add a line, change the sign. Okay? So what's 3 minus 6? -3. What is -5 plus 7? 2. Somebody besides Mitchell, since he's doing this hard work, why do I put this in parentheses and why do I take that out of parentheses? Yeah, because this is negative. I need to square that entire number. If I just left it outside of parentheses, I'd just be squaring the 3 and leaving the negative on there. Okay? But with a 2, you don't really need the parentheses. You can just say 2 squared. Excellent. Mitchell, pick up from there. What do we do next? Okay, what do I get? It's -3 squared. Okay. Why did I put that in parentheses again, Zach? Okay. Mitchell, did you put yours in parentheses? Okay. 9. Okay. So these are always, again, I'm just going to say this again. you always are going to get positive numbers back at this stage. You're always going to get positive numbers back. You should never, ever, ever get negative numbers for this. What's 2 squared? 4. Okay. What's 9 plus 4? 13. Can you simplify the square root of 13 any? Nope. But if you could, you would, right? All right. Does anyone have any questions, 1, 2, or 3? Okay. Rashad, can you help us with number 4? What color you want? Blue. Got it. What do we do first? 5 minus 5 squared. Okay. Sounds good to me. What's 5 minus 5? This is 0 squared, which seems really weird right there. Okay. Got it? What's 0 squared? What's negative 7 squared? So this is like the square root of 49, which is 7. You want to see an easy way of doing this? If you ever notice that one set of numbers is the same, such as the 5 and the 5, you can basically take negative 6 minus the negative 1 to get the 7. So this is basically this part right here. Okay? What that looks like graphically is if I went over 5, 1, 2, 3, 4, 5, and I went up 1, and I went down 6, 1, 2, 3, 4, 5, 6, that's going to be like right here. This distance is just, it's a vertical distance. You can always find vertical or horizontal distances. Okay? If you want, you can still do this. This is totally fine. It's easy. It works. Okay? Just in case you want to know that. Okay. Number 5. Number 5's, it's okay. It's an okay problem. It's a little bit long. I'm going to add a couple things to it just so that you guys can see kind of what's going on for your homework with this. I'm going to pick probably about 3 different people to do it, though, so we'll do it that way. It says determine whether triangle DEF with vertices D, E, and F is scalene, isosceles, or equilateral. What are these 3? What do those 3 mean? What does equilateral mean? All 3 sides are equal. What's isosceles mean? Yeah. 2, and what does scalene mean? None. Okay? Someone said 1 in my last class. They said scalene means one side's equal. One side's equal to what? I don't know. So this is all 3 sides. This is 2 sides. This is 0 sides congruent. Okay? So what we need to do is we basically need to figure out the lengths of those sides, or in other words, the distances between the points. Okay? So in order that we make sure not to like make this repetitive, all I'm going to do is I'm going to find the distance between D and E. I'm going to find the distances between, I'll just say E and F, and then I'll find the distances between, we'll just say F and D. Okay? So I actually have to find all 3 distances of this triangle, the lengths of them, and then we'll basically compare the answers. If they're all, you know, the square root of 2 or the square root of 472, then we know that they're all the same, so it's going to be equilateral. And then we'll just compare at the end. Okay? Let's see. Sam, can you help me with the first one? How do we find the distance between D and E? Tyler Mancuso, be ready for EF. And Christine, FD. 39 minus 6. Yep. Uh-huh. Plus 6. Good job. And subtracting a negative is the same as adding its opposite, so there we go. That's good. So 39 minus 6 is 33, so we have 33 squared there. Negative 6 squared. Okay, now at this point in the game, what I do is I just figure out what's 33? I typed this into my calculator. Say 33 squared plus 6 squared. Get my answer, and I'm just going to throw that in a square root. So it's going to be probably somewhere in the thousands, I would imagine. Make sure you use parentheses if you're going to say that. Okay, did everybody get 1,125? Okay, this is 1,125. And at this point, do I need to simplify it? Do I need to? At the very end, all I'm going to do is basically compare these three numbers. It doesn't ever tell me to actually find them, but I need to have them so I can compare them. Okay? I've kind of run out of room. I could simplify this if I really want. I think it'd be a good exercise too, but I don't technically need to. What's that? Okay, so we're somewhere around 33.5. And I think it's okay to leave these in radical form since we were doing that on the front side, so we'll just leave it that way. Nice work. Okay, Tommy Mancuso, EF. What do I have to do? 39 minus 24, square that. Okay, then what? Sounds good to me. 39 minus 24 gives us what? 15 squared. And what is this other part? Negative 12 minus 18. Negative 30 squared. Let's see, that's 900 plus 225. I think that's the same thing, isn't it? 1125. Sweet. Okay. Now, some of you might have done this a little bit differently. It kind of looks like he may have done FE. As long as he was consistent with which side he started on, like he started with E and subtracted F, he started with E and then subtracted F. As long as he was consistent with that, starting with the same point, ending with the same point, it's fine. As long as he doesn't kind of go backwards. Who was doing the last one for us? Okay. What do we have here? Hold on. 24 minus 6. And we're squaring that. Okay. And what? 18 plus 6 squared. You don't have to say to the squared, but just squared. 18 squared plus 24 squared. And what does that give us? Okay, which is less than 1,025, isn't it? 900 exactly, which is technically that's 30. We don't need to know that, right? Okay, so are these, okay, so the actual question says, are they scalene, isosceles, or equilateral? Isosceles. So our answer here is an isosceles triangle. Okay, lots of work for one answer here. Once you get your homework, you're actually going to, the back side is like this. I'm just going to show you in just a second. Now here's the question, is triangle DEF acute, right, or obtuse? Do we have any idea? Okay, well, how do we do that, though? Do you guys remember? Okay, so which one's the longest side? Maybe this side here? No. It's one of the top two, right? Here's the question I'm asking. I'm doing 900 squared, which is the shortest side, plus the second shortest side, which is 1,125. I'm going to ask, does that equal 1125 squared? Okay, now here's the thing. This is 900 plus 1125. Does that equal 1125? No. Okay? Okay? Generally speaking, instead of writing equal to here, what we're going to do is we're going to say that this side is definitely greater than. And Mitchell learned this with me the other day. He came in, very maturely came in and just talked to me about it. Mitchell, because our hypotenuse is less than the sum of these two, it's smaller, then what type of triangle are we going to have? Acute. It's smaller, so it's an acute triangle. Okay. Last thing says find the perimeter of the triangle. How do you find the perimeter? You add the sides up. So we would just say the perimeter equals, and we would add all three of these sides up. If there's square roots, we would just combine the square roots with it. Okay? Can you guys do that? on your homework, it actually simplifies a lot easier, so that's where we're at. Okay. This is actually a question from your homework. This is the very last question on here. It says, given the vertices of a quadrilateral, okay? Quadrilateral means we have how many sides? 4, okay? So here's the A, B, C, and D. Use the distance formula, okay? We're going to determine if the quadrilateral is a rectangle, a square, a rhombus, or a kite, okay? Rectangle. What would it look like if it was a rectangle? Yeah, it's like if this was 10 and then 20 and then 10 and then 20, that'd be a rectangle, right? Okay, for instance, okay? If it was a square, what might they be? If the first one's 10, then it'd be 10, 10, 10, and 10, right? Okay? If it's a rhombus, what would it look like? All these would be the same, so we'd have to probably figure out something about the slopes, okay? So that's going to be kind of complicated. A kite, you'd have something that would look like this. It'd be like 6, 6, and like 8, 8, something like that. Okay? Or, you know, it could also be this. It could be, if we shifted this down one, it could be 8, 6, 6, and 8. So keep that in mind that, you know, they could be pairs, like kind of separated. Depends on the order that you go in. Okay? But what you're going to do for this problem is you're going to find the distance of AB, the distance of BC, the distance of CD, and then finally DA. And you're going to basically look at those. Part B then says find the perimeter. Does that seem pretty familiar to what we've done just here in the assignment? Okay. All right. So that's basically what your assignment looks like. As long as you kind of keep track of this and remember the actual formula for the distance formula, I think you're going to be fine for this. If you do have questions, though, do let me know. And we are going to be reviewing and taking that test pretty soon.